Hi there. In this video you are going to learn unique things which you will not find in books or in other channels. I suggest that you watch this video to the end and you will be glad you did. I am Nico Michael, an ex-IBMer. I joined IBM 24 years ago, where I was trained in Java, Enterprise Java and the test methodology. What you will learn in this video, I will start by doing a JUnit Maven application. I will show you how to do TDD in a Spring Boot application. I will then introduce you to my secret method, the schizophrenic mock class. And without further ado, let's get into the training. Before we start this lesson, I recommend you open this URL in your browser. So pause the video, open this URL in your browser. In here you will find the code. There's links here to the code and there's links here to the unit tests. As this is a Maven project, there are dependencies we need to add to our POM file. If you look here, you will see the following dependencies. You need to add that to your POM file. And then at the bottom of the POM file, you need to specify the Surefire plugin. So you need to take this as well and paste that into your POM file. I am using NetBeans. If you look here, project files at the bottom there, you would double click that. And then you can see I've pasted this in. Before you can start a unit test, you need to go and right-click the project and say New, Other, select Unit Test folder, select Unit Test, press Next. Give this thing a name. You're going to delete the class it generates. But what it's going to do is it's going to create the dependencies for you in the POM file. And then here we delete this class. And now if you go into your POM file, now you'll be able to add this in there. I've created a class called example test. Now one of the requirements for unit tests is that always your unit test class, the name must end in test, capital T. This is a requirement from Maven as well as JUnit. I have an empty class and I'm going to use this to call some methods in this particular class. I have a class called Operation Performer. It's got three methods. It's got an add method, it's got a concat method, and it's got a return null method. And that will return me a null. I'm going to use this class to do all the different assertions that we need. So the first assertion that I'm going to do is one of the most used assertions in JUnit, and that is assert not null. Notice that I'm calling the assert class the method assert not null, and I'm passing it the result of an operation, and that is calling this concat method. So let's run this. Now I can do it two ways. I can just say test file. Let me click the right place and say test file. And that worked. Notice there is a disabled. If I add this annotation, it's going to disable my unit test. So if I run it again, you'll see this thing will go gray. Gray means it never failed and it never passed. It never ran actually. That's what gray means. I've asserted not null. Now I'm going to do an assert null. In my operation performer, I had a return null method. So when I call this, I will get a null result. And when I run the assert, it should pass because it will be validating that there's a null object. Let's run it. That was assert null. Now I'm going to run an assert true. If you look here, I'm calling the add method and I'm giving it a 2 and a 3. So the result should be 5. And I am saying assert true, and this is a Boolean condition. If you look, you see 5 is equal sum. Now, there is something you need to know. The expected result, we always keep it on the left, and then what we test on the right. Let's run this. And that passed. Now we are going to assert false. So if I add 2 and 3, I get 5. So 6 is equal 5. That should be false. So let's run this. So that is assert false. So remember that this is a useful one. We do use this often. Now I'm going to test assert equals. This is one of the most used. Assert null and assert equals 90% of the time when you write unit tests. These are the two assertions you will use. So let's see. 2 and 3 is 5. Expected result is 5. As I said, our convention, we always put the expected value on the left and the test value on the right. So let's run this. And that also passed. And the last assertion that we are going to look at now is assert not equals. This assertion, we are comparing this number with this number, and we expect them not to be equal. So this should pass. Next, we want to look at exceptions. I have a class called exception thrower. Now this class has a few methods, and all they do is they throw exceptions. Now let's have a look. The first one is argument validator. I'm passing it an argument, and it's checking to see if it's not null. So if it is null, it's going to throw an illegal argument exception. The next one I have is math divide. I'm taking x divided by y, but you see, you cannot divide by 0. You get an exception in Java, and the only way to handle that in a JUnit is this way. Will give you success. So what you do is, in the method, before you do the division, I validate. So I check if the y value is equal to 0. And then I throw an illegal argument exception. And then I put a message in there, you can't divide by 0. So then JUnit can handle illegal argument exception. So it will be able to handle this exception. When you write services that talk to microservices or that talk to the database, sometimes you get an error trying to write to the database or calling an external microservice or any other service. So what we like to do in Java, we like to throw our own custom exceptions. And it's encouraged that you actually do that, because then you can put in the exception why this exception was thrown. For example, failed to write to database exception. Failed to read from database exception. Failed to call external service exception. So these are examples of what I would call a custom exception. In my case here, I just called it my custom exception. And then I put a little message. You chose to throw this exception. So when you call this method, if you pass this text value, a value of throw, and it's case sensitive. Look, I'm using equals ignore case. So I'm first checking that it's not null. Then I'm checking that it's equal or ignore case throw. So it can be any case, uppercase, lowercase, mixed case. As long as those letters are there, then this method will throw the exception. Now let's look how we handle these exceptions in JUnit. So here is my exception thrower test. In this case, I'm going to be running all these tests because they will all throw exceptions. Let's first see what we're doing in the first case. We are going to do a divide by 0. I'm going to call the math divide method, and I'm going to pass it as 0 as a parameter. Now, something you need to know, the assert throws assertion is a special way to use it. We pass it two parameters. There's the class that we are expecting it to throw. So this is an illegal argument exception dot class, and then this is a lambda expression, and in the lambda expression the parameter that we are passing is this operation. So we are calling the exception thrower math divide, and we're going to divide by 0. So as you saw, this will throw that illegal argument exception and it'll put a message divide by 0. That is how we handle divide by 0. The next one, I used that argument validator method and I passed it a null, and it's also going to throw an illegal argument exception. So we handled that this way. Same thing, so assert throws the exception that's going to be caught dot class, and then in the lambda part of the code we put the class and the method called. And the last one, now here I want to throw a custom exception, which is what our exception thrower is going to throw. So what we do here is the parameter that we pass is the custom exception dot class. And then inside the lambda expression, we will then call the exception thrower class and call its throw custom exception method. So let's go and run this, and you'll see 3 tests will pass. And that worked. Next, I want to show you I have created a football teams enum. Now it's a file footballteams.java, but it's declared as an enum, public enum. This thing behaves like a class. You will see that football teams has a constructor. In fact, it has an overridden constructor that gets name, private variable name. So when we call the constructor, we set the name. And then there's a getName method. You see there, getName. So I'm particularly interested in the Buffalo Bills. If you look here, you'll see I'm creating constants. And each constant is declared by calling the constructor. So the constant BUF, uppercase, I'm calling the constructor and I'm passing to it a nicely formatted text, Buffalo Bill, so that I can use this enum to get back the nicely formed text just by saying buff.getName. You'll see that in a minute. Let's have a look at the search engine. I wrote a search engine where I'm passing it an abbreviation. If I passed it a buff, I will get back here Buffalo Bill as the result, Buffalo Bills. This is done in a switch statement. You see, I'm passing the abbreviation as a string. I'm searching with a switch statement. This is like a if, else if. It's much neater than writing a if, else if. What the switch gives me is also a default case. So if none of these cases were found, it'll go to the default, and in there I want to print the message search for, and then whatever they passed me returned no values. Now let's have a look at the class that we used to test it. So this is quite simple. Look here, I called the football search engine .search and I passed it buff. Now we know that when I passed it buff, it's going to return Buffalo Bills. And the expected value is set to Buffalo Bills. So I'm doing the assert equals, and you'll see that I'm going to get that. But whenever you work with strings, always do an assert not null first. So the assert not null will mean that if I got back a null, it's going to end the test as failed, and it's not going to crash the test, which is what I want. But if, in this case, I will get back Buffalo Bills, then I can do the assert equals. And remember, we always said for assert equals, we pass the expected value on the left and the result over there. Till now, we've only been doing positive tests, but we need to also do negative tests. We need to send invalid data to the thing that we're trying to test, and then see that it handles it. In my case, I'm going to send XXX as the abbreviation. I know it's not going to find it, and you remember in the default, we're going to say search for, and then the abbreviation, and then we said returns no value. So that's what I'm expecting to get from this test. And then again, like with the previous one, always assert not null to check that the string is not null. Then we can do the assert equals. Always do it in that order. So let's run this. And you see both passed. I wrote some system outs here. So let's go and have a look at the output. There we are. Found for that. And that one passed. And the other one found Buffalo Bills. So both tests got the expected values. Now there's one thing I want to point out. If you look in the operations performer test, you're going to see that all these tests that we did now, earlier, all these assertions are all there. So your source code is there. But I created a bad test. One of the things that we discourage, do not put multiple assertions in your test. You can test that a string is not null before you assert equals. That's a good practice. But I once worked with a colleague and he had put 6 or 7 assertions in a test. And I thought, oh, maybe I don't know enough about JUnit. Maybe I should put more assertions in my tests. But I found out later it's a bad practice. It makes your tests brittle. It's also a sign that developers write unit tests after they wrote their code. You should never do that. Then you're wasting your time. Don't do unit tests if you're going to write them after you've written your code. The unit test is there to help you test the code while you're building it. You will see that just now. As you can see, this is a bad test. There's about 8 assertions in there. I've now completed the testing of this Java application. I now will be looking at the Spring Boot microservice, doing unit tests on the Spring Boot microservice. After that, I'll be showing you my secret schizophrenic mock class. So stay tuned for that. We will see the following annotations in this project. There's a disabled annotation which allows us to disable certain unit tests. There's also a display name so that we can be able to name the unit test in the display. When it runs, we can see what the which unit test ran. You can give it, it's like giving it a comment. If you don't use this, it uses the method name, but sometimes it's useful to use the display name. And then the order annotation. In this project, I'm able to order the unit tests to run in a certain order. In order to do that, we need to use this annotation on the unit test class, the test method order, and we pass it that parameter. Just a recap, these were the assertions that we ran in the previous project. In this project, we are going to be running unit tests, but we are going to be doing test-driven development. With TDD, as it's called, the business analysts give us the rules. So they will give us these statements, given, when, then, in what we call Gherkin files. So you'll have a given statement, and then we are going to set initial values in the unit test. And then when we put the when statement, we are going to call the service or the class that we want to test. When we have the then statement, we are going to take the results of the unit test and we're going to evaluate them using assertions. So here you can see we have the given, and let me read it out. Given, we have a request with the required fields. When, a record is successfully created in the database, then we should get a successful response. You see now for this IDE, I right-click and say Run as Unit Test. And I gave it a display name, Save Customer Test, and that's what we are seeing there. Now I'm going to demonstrate why you want to use unit tests. When you work with a Java project, you cannot debug the code until the whole project is built. But when you use unit tests, you can debug your code while you are building it. This is a nice feature of using unit tests, and this is something that not many people mention and not many people appreciate. I'm going to demonstrate this to you. I will be testing a class called Customer Helper, and it has a Save Customer method. Ultimately, we will be creating a new record in the database. So if I open the implementation, you will see that our unit test is calling this method, and we've set a breakpoint here. To do that, I right-click on the actual test and just say debug. Or I go to the method. Now you see this is where this IDE comes into. I right-click on the method and I say debug as a unit test. And that's what I'm going to do now. And now I step in with F6. I'm now in the code that I'm testing. So you see, if I created a new method, I would be able to test it. And the principle of TDD goes like this. You first write your unit test, then your test will want to call a class and a method. So you need to create the empty method. When you run the test, it will fail, and that is the principle of TDD. The test must fail. Now we then write some code to make the test pass. So I wrote some code, and now I want to debug that code. I'm able to do that. So I'm now debugging the code I wrote, and you see this helper class is now going to call a service. So if I step into that, this service, first it validates the request, and there was no error. So now it's going to create a customer and save it to the database. Using the request, there's a method that's going to create the customer and save it to the database. And here we are calling the database from the repository. We've now created the record in the database, and the class that I tested, I'm going back to that, and now I'm back in my unit test. So what I've done here, created a method that calls the database. I was able to test it, and I got back a response. You can see from the response that I got a code 200. Now 200 is what we use in HTTP with web requests to indicate a successful response. And here's the message: request processed successfully. So this created a record and wrote it to the database. Before I can use the response, you see, I first assert not null. Now that I've asserted not null, if it was null, my test would fail. But it's not null, so I'm now able to get values from it. And if we hover over there, you see we got the 200. And if we hover over there, we got the success message. Now we can then do assertions, and both my assertions passed and my unit test passed. The problem with that unit test that I just ran through, and that was the reason why I had an annotation to disable that test, is it writes to the database. That's fine while I'm testing my code. I will commit my code to the repository, and Maven will run a unit test on my code. And if the services that I'm calling, or the database I'm calling is down or not available on the network, then Maven will fail to build my project even though the code is good. This is the reason why we want to be able to test. In the old days, we used to pull the network cable out of the laptop. But today with Wi-Fi, you can't do that. But we want to be able to test disconnected to databases and services. And in order to do that, we are going to use a mock class. If you look at this class diagram, we have a controller. Now, normally when people write microservices, they tightly couple the controller to the service class. The problem with that is it makes your project testing unfriendly. So what we do is we do two decouplings. We decouple the controller from the service using a helper class, and then we also decouple the service from the helper class by using an interface. So I make my service class implement the interface. And because I'm doing that, in my unit test, I can create a mock service class that implements the same interface. So my unit test, here's the unit test that tests this class. So I'm now going to couple this to the mock class instead of to the service class like I did in the previous test. And by doing that, I am then able to test the behavior of the service in the mock class without me being connected to the network or to other services and databases. And the variation of this is my schizophrenic mock class. Same design pattern, but you will see the difference. Just as schizophrenic people have multiple personalities, my class has multiple personalities or behaviors. Think of Dr. Jekyll and Mr. Hyde. So here is my unit test. Now before we look at this code, let's have a look at how I implemented my schizophrenic mock class. Remember I said that my mock class must implement the interface, and the customer service is the interface. So the minute I do that, I then land up with a whole lot of methods I need to override. And those are the methods that were defined in the interface. These are the methods, the test methods, that my mock class is going to mock. But I do something special in my mock class, which is unique to this channel. First of all, I make my default constructor private so that you cannot call it. And then I create an overridden constructor where I pass it a test type. And the test type is an enum with three possible values: passing, failing, and throws exception. So those are the three personalities or behaviors of my mock class. And that's what makes my mock class schizophrenic. Depending on which value I passed to the constructor here will determine the personality or the behavior of this class. And then all the methods that I have overridden, what I do in them here, you see, I use a switch statement. And I take the test type, let's say failing test or passing test, and I pass it to the switch statement. So in my switch statement, I've got three possibilities: passing, failing, and throws exception. So if I pass the passing, I'm going to take the response that I've set here, and I'm going to set a success code and a success method and the customer. Like I did in the previous unit test, remember that one that wrote to the database? We're doing the same, but now we're mocking it. However, if I pass the failing, then the behavior is different. I'm expecting to only get an error message and an error code. I'm not expecting to get the customer back. So I can assert for a is null. And then lastly, if I passed a throws exception case, So in other words, when I constructed this, if I pass the throws exception to the constructor, every method in this class will throw an exception. To make it simple, I've just thrown the default exception, but you can throw custom exceptions so that when you do your testing, you can see that you were simulating database not available, failed to write to database. All those type of errors you can simulate with this mock class. So let's go now and look at the test. I have two tests here. The first one is going to be a positive test. As you can see in my mock class, when I'm instantiating it, I'm passing it a passing enum. So this is going to bring back good, happy values, and I'll be able to also get the customer back. So if I assert not null, this assertion will pass. So this is how I can prove that this test worked. The next one, I'm passing it a failing. You see, you want to write unit tests that are not only positive but negative unit tests. And you want to write unit tests where you get back bad data, and that's exactly what this schizophrenic class is doing. It's going to return me bad data. So it won't throw exceptions, but I'll get bad results. And that way I can also test the part of my code that handles bad results. We try to strive for 100% code coverage. That means that all the code in the method or the class that we want to test, we want to cover all that code. So you may have a success part inside a if statement, and then you may have a failed part inside a else statement. And if you only write positive tests, you don't actually get to test the second part. With a negative test, you get to do that coverage. And you also get to strengthen your code because it's handling exceptions. And then the last test is where whatever method I call, it throws exceptions. Now, based on the services that I call, I would throw the custom exceptions that that service has in its methods so that I'm able to replicate failure. And at the same time, I'm able to harden my code because I'm testing my code where I'm trying to make my code crash. And by passing this negative test, I'm able to show that my code could handle failure and exceptions and not crash. So let's go now and run these. First, going to run this. So we run the first positive test, and you can see it passed. I then will run the negative test, and you see this test also passed. And then I will run this test where I'm trying to crash it. Now what you will notice, I have not ordered these tests. So if I run the whole test now, it will run all these tests in parallel, and that's a good way to stress the code. So let's run this whole thing. What I like about this IDE is it shows me all the tests that I ran and that they passed. So Eclipse and IntelliJ are what we recommend in the industry to be used as IDEs, and we use NetBeans for teaching beginners Java. Well, I trust that you enjoyed this training course and that you got some value out of it. Please speak to your friends and tell them about this so that they can also watch this video and learn these techniques that, as I said, are unique to this channel. Thank you very much for watching this video. Please click the like button and also subscribe to this channel to help this channel grow. Have a look in the comments, click on the show more link so that you can see what other videos we have in this series of training courses. Thank you for that.